Let's consider this scenario. There's a police car waiting at rest at the side of the road, and then there is a speeder which just speeds past this police car. And at the moment that the speeder just passes, the police car starts to follow the speeder. And let's assume that the speeder is moving with a speed of 150 kilometers per hour, above the speed, much higher than the speed limits. And then the question is, how long will it take for the police car to catch this speeder? And of course, we will need to make some estimates. We don't have enough information, but we also need to judge whether our estimates are reasonable or not. So let's just make a very simple model of this case. Let's assume the speeder is moving at constant speed. This is the velocity of the speeder. And the police car starts from rest. And let's, for an estimation, let's also assume that it is moving at a constant acceleration. So this is the velocity of the police car as a function of time. Now, then we can use these results for constant acceleration for the displacement of the police car. Let's say that x is equal to 0, x0 is at the position of the car, and let's just call it the x is equal to 0. So the distance covered by the police car will be 1 over 2 at squared. And when the police car catches the speeder, well, they should have covered the same distance. They started at the same point at t equal to 0. They are at the same point at some later time. And since the speeder is moving at constant speed, the distance covered by the speeder will be just the velocity of the speeder multiplied by the time t. And we are trying to find the time t. We know the velocity of the speeder, but we don't know the acceleration of the police car. And we also need to make an estimate of the acceleration of the police car. To make such an estimation of the acceleration of the police car, if you paid attention to advertisements of cars, quite often you hear them quoting that the particular car can go from 0 to 100 kilometers per hour, let's say in 5 seconds. So the change in the velocity of a car is 100 kilometers per second, 100 kilometers per hour, because it started from 0 and its final velocity is 100 kilometers per hour, within a time interval of typically 5 seconds. So the acceleration of this car, which we can use as an estimate of the acceleration of the police car, the acceleration will be 100 kilometers per hour divided by 5 seconds, or this will be 1 over second. 1 kilometer is 1,000 meters. 1 hour is 3,600 seconds. So the acceleration of the police car, we can estimate it to be around 5.6 meters per second squared. So we know the acceleration of the police car. So this is 1 over 2 times 5.6 meters per second squared times t squared. Well, the velocity of the speeder, we also need the velocity of the speeder. This is 150, 1,000 meters divided by 3,600 seconds. And this would give us 42 meters per second. So this is the this is the velocity of the speeder. So 42 meters per second times t. So this is the equation that we need to solve. Well, this equation actually has 2 solutions. This equation is satisfied when t is equal to 0, and it is also satisfied when t is equal to if t is not 0, you can cancel one of the t's, and t is equal to 42 meters per second divided by 2.8 meters per second squared, or this is just 15 seconds. So why do we have these two solutions? You see, this equation tells us that the displacement of both of these objects are equal. At the time t is equal to 0, they are both displaced by 0 meters. So that is what this solution tells us. That is the starting point, actually. At t equal to 0, both cars are exactly at the same point. And also after 15 seconds, again, both cars are at the same point. Note that up to 15 seconds, at first, the speeder is faster than the police car. So although they started from the same point, the speeder goes in the front. It increases their distance until the speed of the speeder and the police car are equal at this time. After this time, the police car starts to approach. It reduces the distance between the speeder and the police car. So it catches up after this point. So that is what this 15 seconds is. So after 15 seconds, the police car will catch the speeder. Now, what about the speed of the police car after 15 seconds? So we already estimated its speed. So acceleration. Now, acceleration is the change in velocity per unit time. So in 15 seconds, the total change in the velocity will be 5.6 meters per second multiplied by 15 seconds. It started from rest, so initial velocity is 0. And the final velocity will be just the change. So this is the final velocity of the police car. And this is just 84 meters per second, or 300 kilometers per hour. So you see, this speed is very high and dangerous. So here we made a very simple model of the problem. And in this model, we estimated the time it takes for the police car to catch up the speeder as 15 seconds. But this model doesn't make it's not very reasonable, because it assumes that the final speed of the police car is 300 kilometers per hour. Now, in real life, especially if the speeder is a reasonable person, let's say, what will actually happen is, when the speeder notices the police car, it will slow down. And the police car, it will accelerate. But after some time, it will just reduce its acceleration. So after acquiring a sufficient velocity, it will lower the acceleration. So in a real life situation, they will not reach the 300 kilometers per hour. But still, the time it will take for the police car to catch the speeder will be typically still 15 seconds.